An air standard engine has a compression ratio of 20 and a cutoff ratio of 5. Intake air pressure 100 kPa 27. Find the working kilojoules per kilogram. So this is definitely a diesel engine because of the term, because we have a given a cutoff ratio. Okay, so first things first, I will illustrate the PBTS diagram of the diesel cycle. So we already know that diesel cycle ay merong SPSV na process. So i-plot ko siya sa PB diagram and PS diagram. Identify yung work na hanapin. Okay. So at the initial state, so low pressure, high volume, no? Naka-expand yung ating piston cylinder. So at this point, so mag-compress siya at constant entropy. So in test diagram, nandito yung point 1 natin, no? Low temperature and low entropy. Okay, this is point 1. So at point 2, magko-compress si piston cylinder. During compression, tataas po si pressure. So sa test diagram natin, so compression means isentropic process. At nag-compress, tataas si pressure, bababa si volume, tataas si temperature. So this is the point 2. Now, we have sinasabing cutoff ratio. So the cutoff ratio is from 2 to 3. So that is constant pressure, heat addition. So dito po nag-add yung heat, or it is the start of the combustion inside the piston cylinder. Kaya po heat addition tong part na to. 2 to 3. And for the 2 to 3 of the TS diagram, so constant pressure process po tayo. Heat addition, raising the temperature and the entropy. Okay. So next is the point 4. So expansion po. So during expansion, from 3 to 4, babagsak na mag-expand na. So bababa si pressure. So same thing, bababa na rin po si temperature dahil expansion, that is an isentropic process. Hanggang dito lang po ibababa niya. Okay, and during, from point 4 to point 1, that is an isometric. So nasa V na tayo, no? V, isometric heat rejection or exhaust, no? Tinatawag na exhaust. That is at point 4. 4 to 1. So exhaust, nabawasan po tayo ng heat. So definitely bababa si entropy. Ganun din po si temperature. And ulit po tayo sa point 1. No? So and so forth, balik-balik po yung cycle ni piston cylinder at diesel cycle. So dito po si heat rejected. Okay, now so the problem is the work. Okay. So find work or the work net. So we all know that this is the diagram of the whole piston cylinder. So we add heat into the system. Nakapag-produce tayo ng work, then merong heat na na-reject. No? Or this is a heat sink. Tinatawag na heat sink, yung heat rejected. So by energy balance, energy in is si QA, energy out, walang iba kundi si work, yung mga arrow palabas to through the system. Si work plus QR. And work simplifying is QA minus QR. So that is the work net. So identify natin itong given. Compression ratio, that is RK. Compression ratio, it is equivalent sa ginalaw ng ating piston cylinder in the compression. So that is from 0.1 to 0.2 in our PB diagram. No? So yun yung volume na kinompress niya. So from 0.1 to 0.2, so that is V1 all over V2. So that is a ratio. So mas mataas yung nasa numerator. That is equals to 20. And we have VC, RC, which is the cutoff ratio. The cutoff ratio is from 0.2 to 0.3. So that is ratio. So mas mataas na sa numerator, that is 0.3. So V3 all over V2 is equals to 5. And at may given tayong pressure. At pressure at 0.1, the initial state is 100 kPa at 27 degrees Celsius. Sa PBTS diagram natin lagay 27 degrees Celsius. Okay. So, hanapin natin si work net. To find work net, we will find for QA and QR. Okay. So, lagyan natin sa kabila si QA. So, solving for QA, so si QA can be found on process 2 to 3. So process 2 to 3 is an isobaric process. So process 2 to 3, isobaric process. So the heat in an isobaric process is Q is equals to M. We will use CP, specific heat at constant pressure, delta T. That is, ang ating delta T will be from T3 to T2. Okay, so elaborate natin. MCP from T3 minus T2. Okay. So, hanapin muna natin si T2 and si T3. Solving for T2. Tingin ulit tayo sa chart natin. Si T2 ay isentropic process, no? From 1 to 2. So, gagamitin natin yung relationship ni temperature kay hindi naman natin pwede gamitin si pressure dahil relationship ng temperature sa pressure at 0.1 to 0.2 dahil wala tayong pressure to na binigay. Pero may binigay na V1 at V2. So, makukuha natin si T2 by using the relationship of temperature and volume in isentropic process. No? So, ito po sa isentropic process. So, the recalling yung relationship ni temperature at saka kay volume at isentropic process for process 1 to 2. So that is T2 over T1, then V1 all over V2, K minus 1. So that is the relationship for isentropic process. So substitute natin, no, para mahanap natin si T2. Because we need T2 para sa MCP delta T natin, no? Which is our equation 1. Okay, so substituting, so we have T2. T1 natin, ang given is 27 degrees Celsius. So kapag when we are dealing with this equation, so kailangan naka-absolute po lahat yan. So plus 273 natin para Kelvin siya, no? Okay, so this is Kelvin. So definitely ating temperature is magiging si Kelvin na rin. So So V1 all over V2, binigay po no, si V1 all over V2 which is our compression ratio. So that is 20. So ano yung K natin? So K, so our substance is air. So ang K ng air is 1.4. So 1.4 minus 1. So T2 will be equivalent to 994.34 Kelvin. So may T2 na po tayo. Next, si T3. Saan po natin nahanapin si T3? Si T3 ay makikita sa 0.2 to 0.3. No? Di naman natin pwede gamit si 0.4, no? 4 to 3 dahil wala naman tayong temperature ni 4. So, gagamit natin si 2 to 3. So, meron naman tayong binigay na compression ratio, V3 to V2. So, makukuha natin si T3. Makukuha natin siya by using this RC, no? V3 and V2, so T3 and T2. So process of 0.2 to 0.3, that is isobaric process, no? So from 2 to 3. Okay, so solving for T3. So the isobaric, so the relationship of pressure to volume at isobaric process is, di ba, PV all over T is equal to PV all over T. Consider natin si P dahil sa isobaric process. So that is T3 or PV, dahil tayo sa basic, no? PVT, P1, V1, P1, P2, V2, T2. Since gawin natin 2 to 3, no? So 2, gawin natin itong 3. So therefore, constant pressure, cancelin natin si P from the combined gas law. Then ayusin natin, no? That is T3 to T2 will equal to V3 to V2. So si V3 and V2, binigay po yan, no? That is your cutoff ratio, V3 over V2, that is equals to 5. So makukuha natin, no? So si T3 unknown, si T2 binigay, nakuha natin kanina, that is 994.34 Kelvin. V3 to V2, this is equals to your RC, your cutoff ratio. So this is 5, no? Tama po ba? 5? 5 nga po, no? So therefore, our T3 is 4,971.70 Kelvin. So i-mark na natin siya rito, ating T3. Ayan, okay na pa, nakamark na pala, no? Si T2, mark lang natin, no? Para madali natin makita. All right. Tapos, okay, so by substituting to QNCP delta T, so substitute na po natin, no? Okay, since wala naman bigay na mass, so ang ating heat, no, per kilogram po, no, kilojoule per kilogram po magiging unit natin. So baba muna natin si mass, no? Baba muna natin si mass. So Q added is equals all over M. So CP ng air, that is, ano po CP ng air? That is 1. No? To be exact, 1.006. Pero yung 1, allowed, pwede na rin po yan, no? That is 1 kilojoule per kilogram Kelvin. Tapos si T3 minus T2, substituting na lang to, no? 4,971.70 Kelvin minus 994.34. So that is Kelvin. So kaso si Kelvin, matitira si kilojoule per kilogram mass. So our QA is 4,001.22 kilojoule per kilogram. Okay. So for our general equation, naharapin natin si QA. Si QR na lang po yung hahanapin natin. So markahan lang natin, no? Ayan. So si QR, But actually, tinry ko na siyang i-solve kanina by using QR since na kulang yung data natin, no? Because QR is 4 process 4 to 1, no? 4 to 1. Hindi natin makukuha si 4. Bakit po? Kasi wala po tayong value um, ni ni pressure 4, no? Hindi naman pwede yung volume dahil 4 to 1 is constant volume process. So, hindi natin makukuha si heat rejected. So, meron pong alternative na formula for solving the work net, no? From the efficiency. Okay, so we will use the efficiency formula. Hindi po itong may heat rejected. So, efficiency formula, okay, efficiency formula, alam natin yan, that is input all over sa output. Okay, ang input natin dito, yung may arrow in, so that is QA. Ang output is si work. Diba? Tapos si work net. Hindi na po sasama si QR, no? Kasama na po siya sa work net. Kasi pag sinama si QR, mag-100% po siya. So, ang nagamit lang po is si work net. So, that is the efficiency. So, we will find, so, the work net. So, definitely work net is equals to E all over QA. So, this is our, the new general equation. So, we will find the efficiency. Okay? May value na tayo ng QA, so si efficiency na lang po yung hahanapin natin. So solving for efficiency, so by the efficiency, so we are using the alternate formula, no? Kasi efficiency po makukuha po by using yung ating compression ratio and cutoff ratio. No? Pwede pong makukuha po natin si efficiency by using the cutoff ratio and compression ratio. So ito po yung formula niya. No? So E is equals to 1 minus B all over A. So yung B natin, okay, the formula for B is, so RC raised to K minus 1 all over K. Binabalang natin si RC minus 1, no? Parang ginambol lang po, no? So ayan po si B. And your A is simply RK K minus 1. Ayan po. Makukuha natin sa efficiency, no, by using the compression ratio and the cutoff ratio. So substituting, so solve muna natin si B, no? Para or isang bagsak na lang natin, pwede rin naman, no? So 1 minus RCK minus 1 K RC minus 1 all over sa RK K minus 1 by substituting 1 minus RC. RC is, ano si RZ? RZ is 5 and RK is 20. So RZ is 5 times 1.4 minus, alamig. Okay, that is 1.4 minus 1 all over 1.4 RC is 5 minus 1. Then at the denominator is RK 20, 1.4 minus 1. Okay, and that is equals to 0.5411 or 54.11%. So we will use this to find, we will substitute this to find our work net in our general equation. So by substituting our E, So work net equals to 0.5411 all our over our QA. Our QA is 4,001.22 kilojoule per kilogram. So definitely our work net is equals to 265.06 kilojoule per kilogram. And that is the final answer. So thank you po and bye-bye.